what to do when there's a quadratic on the bottom of your rational function. Well, what we're going to do first is simply just factor both the top and the bottom as much as we can. Looking at the top, 7 minus 4x, there's nothing we can do here. So that's okay, let's move on to the bottom. I'm going to write it in this more legible form for me. 4x squared minus 8x minus 21. Just keeping this negative in front so we don't forget about it. 7 and 3. 7 times 2 minus 3 times 2 gives us 8. So, minus 2x 7, 2x 3, and the 7 will have to be negative. Keeping this negative in front. So now we rewrite the original equation in this factored form. 7 minus 4x over, I'm just going to bring in the negative this way. 4x minus 7, that looks a lot nicer. 2x minus 7. 2x plus 3. So we're going to look for critical points now. Critical points. These would be, for the top, f at x equals 0. That means the top will be 0. So 4x equals 7. X equals 7 over 4. Next, looking at the bottom, when the bottom equals 0, that will be a vertical asymptote. We have two of them. 2x equals 7 and 2x equals negative 3, for x equals negative 3 over 2 and x equals 7 over 2. Put these in decimal, 3.5, negative 1.5, and 1.75. I'll go down and draw these on my graph right away. We have 3.5, 1.5, and 1.75. Oh, that's the last one's negative 1.5 and 1.75. Let's also just check the y-intercept. So when x equals 0, we have negative 7 over negative 21. Or 7 over 21, which will be positive 1 over 3. So when x is 0, y is about a third, let's say there. Making sure we don't forget, here we have our vertical asymptotes, the 3.5 and negative 1.5, drawing in these vertical lines. X equals negative 1.5, x equals 3.5. And here is just our x int, which I will not label at the moment. So we can see already in the middle some kind of going through the y-intercept and then the x-intercept here. You can guess what it will look like, but to finish off, what we will do is first find our horizontal asymptote. So, but this will be obviously when we take x towards infinity, we have that, we get 4 infinity over 4 infinity squared, so f at x equals 0. Anything with a quadratic on the bottom will have a horizontal asymptote of 0. And then, for our last thing, our sign diagram. So looking back down here, we have our critical points, negative 1.5, negative 1.5, and 3.5 on the number line. So, on the left of negative 1.5, for example, when f minus 2, we get negative on the top, and then negative times a negative on the bottom, so positive. We get that it is negative over here. In the center, let's also add our x-intercept. We already know that here it's going to be positive, and since this is our x-intercept, it will be negative here. So what's left to check is f of something bigger than 3.5, so 4. So positive, 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 we get positive. So negative, positive, negative, positive, with our horizontal asymptote of y equals 0. Let's change the color for this graph. Starting through the middle, following the asymptote, through the y-intercept, through the x-intercept, and following the asymptote. On this side will be positive, so just follow the asymptotes, give it a kind of a curve if you want, and this side negative, following the asymptotes. Beautiful. You've graphed the quadratic on the bottom.